Good evening, everyone. We live in an age of unbelievable progress in the field of computing, with the internet having revolutionized the way information is exchanged on a global scale. It seems like every day the chips get smaller and the computers just get faster. One would think that such changes would have brought about a new age of utopian technology. This, however, is not the case. Yet, in many areas of life, things don't seem to have changed much at all, and the transportation field is a woeful example of this. The science fiction stories of decades past foresaw flying cars and teleporters, but the 21st century has just had to settle for the Segway. Imagine highways with no traffic, transportation with no emissions, run without fossil fuels or any other non renewable source of energy. Imagine being able to travel at the speed of sound, riding on nothing but a layer of air. Impractical and whimsical as this might sound, can you further imagine doing Bombay Pune in 8 minutes? That's probably the hardest of them all, seeing as it often takes many of us half an hour to merely get out of our lanes. Dreams, however, never die, and the concept of futuristic transportation is very much alive right now, as exemplified by a concept called the Hyperloop. As an aspiring mechanical engineer, technology of the future really fascinates me, but there's been no recent invention or concept that's come up with of late which has stirred me more than this one has. So today I'm going to break it down for you guys and show you what this is all about. But before I begin explaining the concept of this engineering marvel that might soon be a reality, let me get your imaginations running wild. Elon Musk, the CEO of Tesla Motors and SpaceX, the man behind this extraordinary idea, has described it as a cross between a Concorde, a railgun, and an air hockey table, while noting that it has no need for rails. So any guesses what it could look like? So here's your first glimpse at a design of it. So the Hyperloop is a proposed transportation system for traveling between Los Angeles and San Francisco in 35 minutes, a current distance that takes over 6 hours to complete. The 4 existing modes of transport in the world right now are road, rail, water, and air. This will be the 5th, a whole new mode altogether. It's a high-speed transportation system, immune to weather, with cars that never experience crashes, an average speed twice that of a typical jet, low power requirements, and the ability to store energy for 24-hour operations. Yep, let that sink in. It's almost ideal in every possible way. So here's how it works. The Hyperloop consists of several distinct components, including the capsule. Sealed capsules carrying 28 passengers each that travel along the interior of the tube depart on an average of every 2 minutes between LA and San Francisco. A larger system has also been devised that allows for the transport of 3 full-size automobiles along with the passengers to travel inside the capsule. The capsules are separated within the tube by a distance of approximately 23 miles or 37 kilometers on an average during operation. The capsules are supported via air bearings that operate using a compressed air reservoir and aerodynamic lift, similar to a puck gliding on an air hockey table. So as you can see in this, the bottom of the capsule has the air reservoirs that give rise to a cushion of air, which the capsule rides on. And this completely eliminates friction between the tube and the capsule, enabling it to attain speeds of over 1,000 kilometers on an average, not even top speed. It's another conceptual sketch of what the Hyperloop capsule could look like. The second major component is the tube. The tube is made of steel with a very low pressure, almost approaching vacuum, so that the capsules experience minimum drag or resisting force in the forward direction. Pylons or pillars with displacement sensors at the base are placed every 100 feet to support the tube. So you can see these, the sensors are located at the bottom of the pillars. And what these sensors do is, they adjust to any movement of the ground, ensuring that the tube remains level at all times, similar to the way the wings balance themselves in an airplane. So this completely negates the effect of any tectonic activity and would keep the tube in the same normal horizontal position at all times. Further, the solar panels will cover the top of the tube, and this will power the entire system. So there's no form of conventional electricity being used at all, neither any fossil fuel, so making it a completely green technology. Traveling at supersonic speeds through a closed dark tube could cause anxiety problems amongst passengers. But this problem would be solved by portraying beautiful sceneries and landscapes on the interior of the tube so that it feels like you are simply enjoying a wonderful view. The third important part is the propulsion mechanism, how you attain that higher speed. So basically, it works on the principle of electromagnetism. So linear accelerators are constructed along the length of the tube at various locations, and these accelerate the capsules. Stators are located within the capsules to transfer momentum to the capsules via the linear accelerator. So if you didn't understand a word of that, it's basically these are the linear accelerators, and these kind of things are located at regular intervals along the tube. So as the capsule passes over them, they accelerate it by the principles of electromagnetism. Now, a major problem that they faced during the design of the Hyperloop was a physics problem called the Cantor-Wood's limit. So what this means is, when you have a high-speed capsule moving through a tube, there is a minimum surface area of the tube to the pod ratio, to the capsule ratio, below which you will choke the flow. So it's similar to a syringe. So if you have a syringe and you have a plunger that pushes through the tube, so what it does is it creates a high pressure region in the front part of the tube. So this, of course, is not desirable because it would cause severe damage to the system. So what Musk has proposed to solve this problem is absolutely brilliant. The solution lies here in the front, in the form of an air compressor or a fan. So what this compressor does is, as the capsule is moving ahead, it sucks in the air that's ahead of it and transfers it around the body to the low pressure region at the back. So although I said that the capsule travels in a vacuum, there's still a little bit amount of air. They cannot maintain ideal conditions. So there's still a little amount of air which would cause a significant problem. And the compressor at the front would completely solve that. So as you can see in the figure on top, the streamlines of air are sucked in through the front part, which is the compressor fan. And this transfers the air over and around the capsule, thus preventing any friction ahead of it. So there will be a station at Los Angeles and San Francisco. Several stations along the way will be possible, with splits in the tube. The majority of the route will follow the 1-5 interstate, which is the current highway between the two cities, and the tube will be constructed in the median, so in between the two roads. The Hyperloop is sized to allow expansion as the network becomes increasingly popular. The capacity would be 840 passengers per hour, which is more than sufficient to transport all the 6 million people traveling between LA and San Francisco every year. In addition, this accounts for 70% of those travelers to use the Hyperloop during the rush hour. The low cost of traveling on the Hyperloop, which is estimated at about $20 for a one-way trip, is likely to result in an increased demand, in which case the time between capsule departure would be significantly shortened. The cost of this entire project is estimated at about $6 billion. That might sound a lot, but it's significantly less than the current high-speed rail system, which is not even half the speed of this, and that's being proposed at $90 billion. So now, most importantly, when can we expect to ride in one of these? A prototype of the Hyperloop has almost been completed and should be ready for testing in the first half of 2016, as estimated. So here we have, there's a 1-mile long test track being built in Las Vegas, where many companies and colleges will be allowed to test their prototypes, following which the most feasible design will be selected. So SpaceX is not manufacturing the entire thing by themselves, but what they've done is they've given the specs, they've released a whole manual about how this thing is going to be worked, and they are encouraging other research companies and colleges to develop the design, and then after which the most feasible one will be selected. So hopefully sometime in the next decade, we should see the first Hyperloop in America. And back here, I mean, hopefully some of us will even be alive to see this engineering marvel come to life. Thank you.